Hello, everyone. So, welcome to this last session before lunch. Today I bring you Unlocking the Power of Data-Centric AI while Mastering Data Preparation for Machine Learning. My name is Fabiana Clemente, and I'm Chief Data Officer at Y-Data. Just before bringing you all the stuff around data preparation, a few words about myself. My background is in applied maths and data science. I've worked from big enterprises to small startups, so I do have my fair share of differences between a data architecture in a big corporation and really how do you operate data at a small scale, not a small scale, but at a small company for sure. My passion definitely is data science, though I have a particular interest for time series and generative models. Feel free to connect with me on LinkedIn. More than happy to exchange some ideas, especially after the talk or any other day. To start with, and why I'm going to start by foundational models. Well, data preparation have been for quite some time around, right? But especially in this era where we see foundational models everywhere, from images to text, we have DALL-E, we have ChatGPT, they have changed the perspective that we have around data and how we prepare it. These models, these foundational models, they are trained on broad data sets of unlabeled data, which makes them, of course, very special. They are, as many may say probably, the future of AI. And they are not only reusable, but they are also very flexible when we compare them to previous models of AI, which makes them quite applicable to any domain or any industry. But even though these large models can cost millions sometimes to train, each new generation produce more and more accurate results. And this is very enticing for the future of the industry. And, we might even think that given that these models trained with a lot of data are so flexible and so good, this means that we might not need great quality data after all. We can train in big pools of data and that will ensure us results anyways. And truth to be told, we have seen the impact of these models as well on the landscape of tooling, as you might imagine. So the impact is not only at the application level, but also on the tooling of AI. So large language models are definitely bringing new tooling to the space, new ways of developing AI, and all of that is kind of reshaping how we see the AI development. But one thing haven't changed yet, or at least that much. You might think, garbage in, garbage out, that's over, no more problems with data, we got it sorted. Not quite. So we are still having the same issues as we used to have on the data preparation side. So on the data preparation, on the quality of the data that you have. So some may say it's the labels that are inconsistent. Some may say that it's the data that is not enough for the use case that you want to solve. Is the representativity of your population. There are a lot of aspects around data that still impact these large language models. And you can take, for example, articles like we have seen published, like Chinchilla, where a model that is way smaller perform way better than a model that is bigger, trained with more data, just because the data that was used was accurate. And that's why, and still, even though we have foundational models, in the end, it is still all about the data. So far, if we go and check the available open source foundational models, and that was actually referred in many of the talks today, they are still trained on open source available data, which means that in order for an organization to differentiate or even someone that is just trying to use foundational models in an application, they will need to have special attention or pay special attention to the data that they use either to fine-tune for the RAG or even just to train again the model. And that will be the difference between what you see open sourced and the performance that you will have from training your own model. And well, that brings us to the data-centric AI aspect of AI development. So far, our focus have been on the model. So perhaps many of you know this process by doing a data preparation. As an engineer, you kind of clean some messes regardless of the model that you are going to use. You then have a model that you train once, and you do hyperparameter tuning. At this point, when you are doing your hyperparameter tuning on the model, your data is fixed. You assume that that's your artifact, and that's the data that you are going to use for your model, regardless. So the only thing that will change and iterate is actually your model parameters. In the data-centric AI context, this is a bit different. What is said, and this was even stated by Andrew Yang, so he was the first to coin the term data-centric AI, is that this process shouldn't be like this. So in a nutshell, your data preparation shouldn't be completely detached of your end application. So even if it's a machine learning model or even an analytics application, you need to optimize your process or your data preparation towards your end objective. In this case, your fixed system is the code, let's say the model, and not the data. And the data is actually your iterative process. So it's like doing hyperparameter tuning of your data preparation, of even your data. That's what I call treating your data as your product. So thinking data as a product means that you should put your data in the context of the business needs and at the heart of your data flows and data preparation design. So don't think about your data preparation or your ETL job as something that is independent from the rest. It's actually part of your product. It's actually part of your development. And it's a living system that needs to be iterated. So, a question that some of you might have, but what does it mean to have this high quality data to achieve the highest results, and what does it mean to iterate this data? What is the objective? What will we focus on? So it does depend. It does depend on your goal, it does depend on your use case, and actually data quality and what we call to be the objective of a great data preparation for AI have multiple phases and will depend on the context and use case. So just for you to have an idea, there's an article that states that there are more than 70 aspects that can be measured as data quality. So it can be just accuracy, completeness, consistency, integrity. It does depend. But those aspects are the ones that you should add to your objective function when you are trying to optimize your data preparation flow. And well, this is very good, this is very interesting, but how can we just translate data-centric AI into practice? What are the best practices that we can follow, and what are the tools that we actually can adopt on a day-to-day and while doing our data preparation in our process in order to have better AI development? One of them, perhaps for many of you, it's obvious or it's something that you already do on your day-to-day, data profiling. So in a nutshell, data profiling summarizes all the essential properties of a data set, allowing different data sources comparison and a thorough analysis of the available data. Better data management means improving your data quality over time. What do I mean by this? Many, in some organizations or in some places, and we actually have seen that in the previous talk, this step is done manually and in an ad hoc manner. Many people build their own validations every time they need to check the data. They build their own visualizations every time they need to check the data. And the fact that different people end up building different systems to validate the data, it leads to a different understanding of exactly the same data. This might seem like something surprising, but it's not that uncommon. if you do the same different validations or you have a different understanding of the same question, you will implement validations that are different, and that will lead to different results. So that's why the data profiling should be, in a nutshell, a standardized method. Can be defined by the business, it can be standardized based on the machine learning model that you want to use, or even can be just based on the end system that you want to build, like a bunch of expectations, for example, that you want your data to meet. But what is important is that this process is standardized since the beginning and is actually the first step in your data preparation flow. And have in mind, this step you won't be using just once. You probably will be using several times throughout the process of development. After all, you want to validate always the changes that you are making, the decisions, how the decisions that you are doing in terms of the data preparation might change or are changing your distributions or the data behavior. And of course, data profiling can be done with several different components. It can be done through visualization. A lot of teams do prefer visualization because they are actually more actionable when compared to other methods. Can be automated analysis through statistical methods and scores, or it can be just by expectations and business rules. It does depend on the use case. It does depend on your end goal. Second, and this is probably one that might be not so common, but definitely one that is dearest to my heart, is synthetic data. So synthetic data is something that in the toolkit of data preparation can make a lot of difference. I'll start by the question that you might have at this moment, which is what is synthetic data? Synthetic data is artificial generated data that was not collected from real-world events. It keeps the same characteristics as the real data and is not traceable back to original individuals. So how can one use synthetic data just to make better data preparation? So it might help you to have access to data way faster, because if privacy regulations are in place or you have a tight security system, you will want to have access to a data that has no privacy concerns but still holds the same value as the original one. And that's what synthetic data can deliver you. Or perhaps you might want just to stress test your system during data preparation, and you might want to have a data set that actually reflects corner cases, edge cases, or different types of behaviors based on your understanding of the business. Sometimes the data is just hard to collect. You don't have those events, but you know they might happen. So synthetic data can be an answer. And well, there are different types of synthetic data, and not all the synthetic data is the same. Probably some of you are already familiar with what is called dummy data. So this randomly generated data that holds the same format or the same look and feel as the real data, but has no value to be used for analytics or machine learning. So it's just a dummy data set. It is great to test schemas. It is great to test data flows, but it's not that useful if you want to build something else on top. Then you have what we call data-driven synthetic data. And this is where we use generative models to generate synthetic data that holds the same value as the real one, but have no privacy concerns. So in this case, we use models to learn the original distributions and make those distributions replicable. So it's not only a case of you can generate more data, but actually you are compacting your business information into a single model and use it every time you want new data to share with different teams, for example, to build sandbox systems or just to test different scenarios. And that's where simulated data comes in. So this is the case where you have currently, for example, a population, and you want, for example, for a specific city, you have data from a specific city, and now your organization wants to go to CDB. They have never sold anything on CDB, but they want to be able for their system to still work when they start their business on CDB. So what you do is grab your data from the first city or the cities where you are actually, or where you have data from, and you can simulate the data for CDB under assumptions that you know from the market. That's where simulated data can be useful. This will allow you to, well, not having problems or not having data and starting right away to operate on a new location will allow you to have more robust systems and more generalizable systems as well. So very quickly, why go synthetic? It's cost efficient when compared to data collection. So if you have no data and you are able to simulate it and have it with the right accuracy that you need for your use case, why not? It can unlock data sharing, supports responsible AI. After all, you can use synthetic data to balance populations, for example, that are underrepresented. It can bring more machine learning performance. It can enable faster product testing and development. But of course, and especially around data preparation, and this was also mentioned in the last talk, nothing is more important than reproducibility. And when you are in a data-centric AI perspective and you want to make sure that your whole flow of data-centric AI is aligned with your objectives, whether it's correctly measured, and you can make it reproducible for time or even versionable, data orchestration is a very interesting option. For example, let's assume data pipelines. You probably are somewhat familiar already with the concept, Airflow, DAGs, all of those can be considered data orchestrators. You can use them, and they can be very essential for organizing, tracking versions, and ensuring the consistency around your old data preparation. They manage the flow of your data, they clean, they structure it, the analysis, and they can also allow you to integrate very effectively your data preparation along with AI. And that's very important, especially if you are optimizing your data preparation towards, for example, a machine learning model. By incorporating versioning and reproducible features, pipelines can enhance the reliability and transparency, ensuring that your data processes can be easily traced and replicated. So, for example, let's say, and this is a very common decision, you have a specific data set and you decide to standardize a specific distribution. We all know that in case the distributions are skewed, this is the best, might be a good option if you want to build a model on top of this data. You run a certain decision around standardization, and you check how does that impact, for example, the scores of your model. Afterwards, and because you know that you were trying two different standardization models, you want to test another method. And you want to compare the results of both in order to decide the best. Data pipelines are the ones that allow you to do that version and allow you to make that process not only comparable, but also versionable. So you won't lose the first decision, the decision of the model A versus the model B. You will still be able to decide between a specific standardization or another one. Another example might be, for example, how do you deal with inconsistent records? So records that have issues. Do you delete them? Do you impute them, or do you change them? All those decisions do impact your machine learning model in different ways. I'm not saying that one is worse than the other. It just depends on your business, on which one might be the best, and of course on the issue. But you want to be able to test the three of them and choose the best one, or the one that optimizes the best the performance of your model. And that's where pipelines can really be helpful. But of course, all of this is super important, but another point that you should always take into consideration, and along with pipelines, is data version control. So it doesn't matter, you have a pipeline, you have the code of your data preparation versioned, you have your code for data preparation comparable and traceable, but you don't have your data versioned. That's probably the last element that is quite important for to making your process fully reproducible and robust. You can use, of course, GitHub is a possibility, but it's definitely not the best practice. But there are other tools specific for data version control that you can use. You can, of course, set up your own. It depends on the organization. But that is a must when to combine with data orchestration. Otherwise, definitely, even though you have your all flow fixed, your results won't be reproducible. Okay. So with this, I want to end my talk. I want to invite you to join Fabric Community Version. This is the product that YData is developing. We have a data catalog with automated data quality profiling in case you want to make sure that you standardize your analysis. Of course, we can help you with any synthetic data generation that you might require. And last but not least, all these processes can be versioned and iterated on our data preparation flows. And in case you just want to give it a try, experiment, and you really like code, we also have open source, both the profiling and the YData synthetic, so you can build your own systems, your own flows, and try it yourself, perhaps integrated with your tools or just locally. I hope you have enjoyed, and thank you. I think we have some time for questions, so feel free. Okay, so thank you, everyone. Oh. Hey there.
I was just wondering, for generating data that you say replicates the same characteristics, how deeply do you retain the same distributions? Like, how detailed does it get? For example, this field may have this distribution, but then when you pick up quantile of that, depending on that, the other field will have certain distributions. So how, like, you can get very detailed, but that can get really complicated. So where's the balance?
That's a very good question. So usually, and this is, well, the advice I gave here, we usually use also for the, for example, the synthetic data generation process. The best way, one thing that highly impacts exactly the accuracy or the performance of how you can replicate very well the real data is the model that you choose for your data. So depending on the metadata and the profiling of your data, different models will play best or have a best performance. So for example, if your data set is very small and have a lot of categories, you might prefer a generative model like a Bayesian network that is smaller but can understand a bit better the causality between the different categories. But let's say that you are dealing with a large volume of data, very big, with a lot of numerical variables and if just a few categories. So scale is important for sure, but and you have just a few categories and a lot of numerical, so you want to have something that can assess multivariately very well your data. You can go for a transformer, for example, or even again, they will be able to replicate the details of the distribution of your data. Of course, you might want to pay attention where you have imbalanced behaviors as well. So in that case, the GAN is not the best, and you might want to go with the chained version, for example, of the GAN, which allow you to condition the generation so you can have that replication of the less represented population, let's say. So it does depend. But usually, if you know really well your data, the generative model that you select will ensure that replication. But you really have to know the data. I'll be available for Q&A later on, so be happy to chat with you. And thank you, everyone.